Hi students, welcome back to Ramana Sir Physics channel. Today I would like to say the topic is laws of motion. Okay, in this laws of motion topic we'll discuss about the Newton's laws. There are three laws are there: Newton's first law, second law, third law. Before discussing these topics, first of all we have to discuss about the scientist Newton. The scientist Newton, so one day he sat under an apple tree. Okay, one apple fruit fell down on his head. Generally, the normal person what will do? So take that apple fruit and they'll eat. But the Newton is scientist. He thought, why this apple fruit is falling downward? Why not it is going upward? One doubt arose in his mind. So that reason only, okay, he discovered these laws. So from this incident, okay, he concluded Earth having gravitational force. Then he proposed Newton's, okay, universal law of gravitation. Newton's universal law of gravitation, and then laws of motion. So in these laws, there are three laws of motion are there. In that first law, Newton's first law, Newton's second law, and Newton's third law. So there are three laws are there. So in Newton's first law, what it says? Okay, in Newton's first law, it says every body wants to be continuous its position, its state of rest or of uniform motion. For example, uniform motion body wants to be, okay, continue its position, uniform motion only, and rest body wants to be at rest only. Okay, unless external force acts on the body. Unless external force acts on the body. So for example, we can observe. So here this pen is there. So the pen is at rest. Okay, if I not applied external force on this body, so the body at rest only. The body at rest only. For example, it is uniform motion. So if we applied some force, then only the body comes to rest. The rest body wants to be rest only, and uniform motion body wants to be you continue to uniform motion only. So that is Newton's first law. It gives the concept of inertia and force. Newton's first law gives the concept of inertia and force. What is inertia? So inertia means it is the inability of a body. The rest body at rest only, and uniform motion body at uniform motion only. So here inertia are three types are there. Inertia three types are there: inertia of motion and inertia of direction. So we can check on, okay, board. Inertia of rest means what? Okay, so the rest body wants to be at rest only. So the good example, passengers standing in bus, okay, so they feel backward jerk when the bus driver starts suddenly. Bus driver starts suddenly. Okay, so another example also we can take. So the carpet, dust carpet, so we are hitting with stick. So what happened? Dust particles are separated by a carpet. Okay, so next one, inertia of motion. The passengers standing, okay, and traveling in running bus. The bus driver applied sudden brakes. They feel forward jerk. So that is inertia of motion. So they wants to in motion only. So the bus driver applied brakes. So bus comes to rest, but the body does not comes to rest immediately. So another example also. So from the running bus, okay, the passengers, okay, so moving away. So what happened that time? So they feel forward jerk. They feel forward jerk. The last one, inertia of direction. So the bus is moving, okay, in straight direction. For example, the driver turned rightwards suddenly. Okay, the passengers they feel, okay, leftwards. They thrown away or leftwards. They feel like that. So this is inertia of direction. Okay, Newton's second law. Okay, the Newton's second law states that, okay, so the rate of change of momentum is directly proportional to the external force acts on the body. Okay, so here we are discussing rate of change of momentum. Here the one word momentum is there. Momentum means what? So before discussing second law, we have to discuss about the momentum. So what is momentum? The momentum is the product of mass into velocity. Product of mass and velocity. The momentum is the product of mass and velocity. Okay, here mass and velocity. M is what? Mass. M is mass of the body and V is velocity of the body. Velocity. Okay, so what is the SI unit of momentum? The unit of momentum, SI unit is mass unit is what? Kg, and velocity unit is what? Meter per second. Kg meter per second. Okay, here the Newton's second law. The rate of change of momentum is directly proportional to the external force acts on the body. Okay, takes place in the direction of in which the force acts. According to the definition, so we can take F is directly proportional to the rate of change of momentum means what? Dp by dt. Okay, here proportionality symbol cancel in time. We can write one constant equal symbol and one constant. I am taking the constant is k. And here P means just now we discussed mass into velocity. D by dt of mass and velocity. Okay, here F equal to K into this I am writing outside M into dV by dt. Okay, therefore F continuation F equal to K into M into the rate of change of velocity is what? Acceleration. I'm taking A. Okay, so here if 1 Newton of force acts on a body, 1 Newton of force act on a body, okay, and body of mass is how much? 1 kilogram of mass. Body of mass is 1 kilogram. Okay, so that time body is moving with 1 meter per second square acceleration. So that time the k value what happened? Substitute all values. 1 equal to k into 1 kilogram mass and 1 meter per second square acceleration. K value what happens? K value is 1. Therefore k value 1 means what happened? F equal to ma. So from using this Newton's second law, we can derive the F equal to ma derivation. F equal to ma derivation. Here force SI unit is what? Newton. On scientist name only, the SI unit of force is what? Newton. Here about force, some cases we'll observe. For example, a particle is moving in the straight direction and hitting with the rigid support like wall. Okay, then after hitting it is going straight. Okay, after hitting it is coming back with the same speed. It is moving with the speed v. Okay, so same coming with the speed also v. The mass of the body say m. Okay, so that time change in momentum. So change in momentum is what? The initial momentum and final momentum difference. Here initial momentum, okay, mv only, final momentum also mv only. Why? Because same velocities. Okay, so then what we can take? The change in momentum, so we can take delta p. So change in momentum is denoted by symbol what? Delta p equal to, so mv, so the moving time mv, so minus of minus. Okay, a minus of minus, while written also with the same speed only it is coming, so that is why minus mv. So minus of minus, what happened? Total, so 2 mv plus mv, 2 mv. Okay, delta p equal to what? 2 mv. So then the force, okay, the force is what? The rate of change of momentum only force, right? So we can take 2 mv by t, we can take the 2 mv by t we can take. So next another case, okay, so the body is, okay, moving certain angle with the normal. Okay, so then it is rebounded with same angle. Okay, so here you can observe the angle, the body angle is moving with the, okay, so making an angle theta with the normal. So that time what happens that time? So this is a horizontal, okay, so that is why horizontal means what? Cos angle will get. So that is why the change in momentum here, what will get? Delta P equal to 2 mv cos theta will get. 2 mv cos theta will get. Okay, so like that only the force, what will get? Force, the rate of change of momentum, so that is 2 mv cos theta by t will get. Okay, next, if the body angle making an angle with the surface, so the surface angle body, okay, and surface angle is say phi. So that time again after hitting the rigid body, what happened? It is coming back with the same angle. So that time momentum is what? Change in momentum is what? Delta P equal to, here the vertical angle, so that is why 2 mv sin phi. 2 mv sin phi. If force is what? We know that force is what? The rate of change of momentum dp by t. Okay, so the rate of change of momentum, so delta p is what? 2 mv sin phi by t. Okay, so like these cases they can ask, okay, about force. Okay, and other cases also there. Based on these cases, first we'll do some numericals. Okay, so then other cases also I'll explain. Okay, so don't skip the video, so watch till end, so you'll get the all types of, okay, so these Newton's laws problems, numericals you'll get. Okay. So problem you can see on the screen, you can observe the question. A vehicle of mass 20 kilograms is moving with a velocity of 4 meters per second. Find the magnitude of the force that is to be applied on the vehicle so that the vehicle have velocity of 1 meter per second after traveling a distance of 20 meters. Okay. So here what they are saying in this, okay, here you can observe one vehicle is moving. Okay, so with what velocity? Initial velocity is given. How much is given? 20 meter per second. Okay, so a vehicle of mass is given, 20 kilograms is given. 20 kilograms. Okay, this is a mass. Moving with the speed, how much given? Moving with the speed of 4 meter per second. 4 meter per second. Okay, so here initial velocity how much? 4 meter per second. Okay, so it travels certain distance, that distance also given. How much given? This 20 kilogram mass body, so travel, okay, certain distance. Okay, so how much given? Distance 20 meters given, and 20 meters. Okay, and final velocity of the body also given 1 meter per second. So then what they are asking? How much force applied on the body or vehicle? Okay, how much force is applied on the vehicle, they are asking. How to find how much force is acting here? Initial velocity, final velocity, and displacement is also given. Okay, so from formula, the Newton's second law, F equal to ma formula will take. F equal to ma formula will take. So here acceleration we don't know, not given. So from another formula, so Newton's, okay, equations of motion, there are 4 formulas are there. So if you want, so you can check in description. Okay, about equations of motion we detailedly discussed. Okay, here from that v square minus u square, third equation I am taking. So which formula? From v square minus u square equal to 2as formula I am taking. So from this acceleration is what? V square minus u square by 2s. Okay, substitute here F equal to m into v square minus u square by 2s. Substitute the values. F equal to m is how much? 20 kilograms. V square, so that is 1 square minus u square, okay, 4 square by 2 into s is how much? 20 meters. Okay, so here F equal to 20 into 1 square 1 only, minus 4 square is 16 by 2 into 20. So 20 20 gets cancelled. Okay, how much? minus 16 means minus 15 by 2. So that is magnitude I am taking. Okay, so how much we can take magnitude of this one? How much? So minus 15 by 2, that is 2 1 ja 2, 7.5 ja. So that time how much? 7.5 newtons. 7.5 newtons. Which option is correct? So you can check on screen. Third option is correct. Okay. Next problem you can check. A ball of mass 600 grams strikes a wall with velocity of 5 meter per second at an angle 30 degrees with the wall and rebounds with the same speed at the same angle with the wall. The change in momentum of the ball is. So which case is suitable? So here what they are saying, okay, so the third case we can apply. So the ball is, okay, so making angle with the surface they are saying. Okay, so the change in momentum what they are asking. So find the answer. Okay, answer of, so how much change in momentum they are asking. Okay, so changing momentum purpose, what is the formula? Delta P equal to 2 mv sin theta. Okay, so here 2 into mass, how much given? 600 grams given. Convert to kilogram. How much? 10 to the power of minus 3. And velocity how much? 5 meter per second. And angle is given 30 degrees. Sine 30 degrees. Okay. Here 2 5 ja 10 I am writing into. Okay. 600. 2 zeros purpose. Okay. 2 decimals cancel. Okay, 6 into 10 to the power of minus 1 into, okay, sin 30 value how much? 1 by 2. Here now you can observe 10 power of minus 1, this 10 cancel, 2 1 ja 2 3 ja, therefore 3 units are what already they given in options, kg meter per second. Therefore the change in momentum is 3 kilogram meter per second. So which option is correct? Fourth option is correct. Next question you can check on screen. The driver of a three-wheeler moving with a speed of 36 km per hour sees a child standing in the middle of the road and bring his vehicle at rest just in time to save the child. The average retarding force on the vehicle is, okay, within the bracket, the given mass of three-wheeler is 400 kilograms and the mass of the driver is the given 65 kilograms. In this numerical what they are saying, okay, so one driver, so after observing, okay, one small child on the middle of the road, he applied brakes. Okay, so after applying the brakes, okay, after 0.4 seconds the vehicle comes to rest. Okay, so then how much force applied on the vehicle they are asking. Here mass of the person also given and mass of the vehicle also given. Okay, using this data we can find out. Okay, so here the velocity speed of the vehicle is given. How much given? V equal to 36 kilometer per hour given. We have to convert to meter per second. We know that, okay, kilometer per hour to meter per second. How to convert? Into 5 by 18. Okay, so 18 1 ja 18 2 ja. So how much here? So 10 meter per second. The speed of the vehicle is how much? 10 meter per second. So this is initial speed. So we can take u. So here, okay, the mass, total mass is equal to the vehicle mass 400 kilograms plus person mass 65 kilograms. Total how much? 465 kilograms. Okay, so here after applying brakes, okay, after how much time they brought to rest? 0.4 seconds. Okay, 0.4 seconds. So the body came to rest. So 0 will take. How much force is acted applied on the vehicle asking. Okay, same from formula F equal to ma formula. F equal to ma taking. Here which formula is suitable? Here initial velocity, final velocity and time also there. From equations of motion, first equation we can take v equal to u plus at. M into, okay, v equal to u plus at means a equal to what? V minus u by t. From v equal to u plus at, a equal to what? V minus u by t. F equal to M value how much? 465. Okay, into V minus U, 0 minus U is how much? 10 by T is how much? 0.4 seconds. Okay, so now F equal to 465 into, okay, minus 10 by 0.4. Okay, so we can write decimal if you remove. So here 10 you can take. So here 4 1 ja 4, 25 ja 100, 465 into, okay, 25 you can multiply. So you will get 11,625. You will get 11,625 newtons you will get. Okay, so in this 11,625 newtons, but in options they given 1.2 like this given. Okay, so according to that, which option you can take? Here F equal to 1.16 is there now, so round off they taken 1 2 3 4. Okay, the 4 10 power of 4 newtons. Which option is correct? 1.2 into 10 to the power of 4 newtons. Which option is correct? The second option you can take. Okay, next problem you can check. A horizontal jet of water coming out of a pipe of area cross section 20 centimeters square hits a vertical wall with a velocity of 10 meter per second and rebounds with the speed. The force exerted by water on the wall is. Okay, so here with the help of the water pipe, okay, with the help of the water pipe, so what happened that time? So it is, okay, so forcing on one rigid wall. So what happened that time? Water with some velocity, moving with some velocity. So after hitting the surface, what happened? Rebounded. Okay, so they given the area of the pipe is given, water pipe area. The area of the pipe is given, area of water pipe is given. Okay, so how to find the exerted force? Rebound purpose, exerted force formula is what? Okay, so we'll see. So rebounded force, okay, exerted force whenever water rebounds, so that time we can take 2a v square d, 2a v square d. So here a is what? Area of cross section of the pipe. Okay, area of the pipe, area of cross section of the pipe. Okay, and v is what? Velocity, what speed the water is moving. Okay, and d is what? Density of water. So we know that that is 1000 kilogram per meter cube. Density of the water is how much? 10 cube, okay, kilogram per meter cube. We know that. Okay, so in this case rebounded, so that is why 2a v square d we taken. So if the water deads there only, means, okay, so not rebounded, so water falls along with the wall there only, so that time we can take the time a v square d. So it is divided, okay, it is rebounded, so that is why 2a v square d we taken. Substitute the values. F equal to 2 into area of cross section 20 centimeter square given. So centimeter square, 1 centimeter square, 1 centimeters means we know that 10 power of minus 2 meters. Okay, minus 2 meter, okay, whole square, so that is 10 to the power of minus 4 meter square. Okay, centimeter square equal to how much? 10 to the power of minus 4 meter square. And velocity, so what speed the water is moving? 10 meter per second, so 10 square I am taking. Okay, and d, density of water is how much? So 1000 kilogram per meter cube. Substitute here. F equal to 2 to the 4. Okay, so 0, 2 into 20 is 40. Okay, 10 to the power of minus 4 into 10 square, okay, into 10 to the power of 3. So here it is very clear, 10 power of 3, okay, here 1 is there, 10 power of 4, 10 power of plus 4, 10 power of minus 4 cancel, 4 into 10 power of 2 means how much? 400 newtons. Force unit is what? Newtons. 400 newtons. Okay, which option is correct? Third option is correct. Next question you can check on the screen. The linear momentum of a particle as a function of time t is given by p equal to a plus bt, where a and b are positive constants. The force acting on the particle is, okay, here one equation is given, p equal to a plus bt. A plus bt given. Here what they are saying, A and B are constants. A and B are constants they are saying. Okay. So what they are saying, so the force acting on the particle, force is how much they are asking. Okay. So force and momentum, P is what here, momentum. Force and momentum relation, we know that. So what is the relation? The force F equal to the rate of change of momentum dp by dt. F equal to what? The rate of change of momentum, that is dp by dt. Substitute the p value, d by dt of p is how much? A plus bt. A plus bt. Okay. Here differentiation, we know that separately individually we'll do the differentiation, d by dt of A plus, okay, d by dt of bt. Okay, so anything, the constant differentiation of the constants how much? 0 plus, okay, so this constant in the bt, b is constant, I am writing outside. So d by dt of t is how much? 1 only. So therefore force F equal to how much? Just b. F equal to how much? B. So therefore which option is correct in this? The second option is correct option. Question you can observe on the screen. An impulse I is given to be a body changes its velocity from v1 to v2. The increase in the kinetic energy of a body is given by. Okay, so here the impulse. So here impulse means what? So it is nothing but change in momentum. So otherwise another definition also we can take, large force acts on a body at short interval of time. So that is called impulse. Okay. So example, so in the cricket we can observe, so whenever, okay, batsman wants to hit the sixer, he applies force a large amount, but the contact between ball and bat is, the duration is very small. Here large force acted at very short interval of time. So this is called impulse. So in, okay, change in momentum also we can write impulse I equal to, so we can write change in momentum. So the final momentum minus initial momentum, we can write m into v2 minus v1 we can write. Okay, so in this what they are asking, the change in kinetic energy asking. Okay, so change in kinetic energy delta ke, kinetic energy formula we know that half mv square. Here change in kinetic energy they are asking, so half m v2 square minus v1 square, half m v2 square minus v1 square. Here half m, okay, a square minus b square type is there. What is the formula? A plus b into a minus b, a plus b into a minus b. Here instead of v2 minus v1, from this equation I want to write, okay, so I by m equal to what we can write? v2 minus v1. From this I equal to m into v2 minus v1, v2 minus v1 equal to what? Okay, I divided by m. So I want to write here of m v2 plus v1 into, instead of v2 minus v1 writing I by m, writing m gets cancelled. Okay, so therefore change in kinetic energy is equal to, so we can write, okay, v2 plus v1 or v1 plus v2 into I divided by whole divided by 2. Here four options, which option is correct? So they given I is before given, no problem. Okay, I into v1 plus v2 by 2. So here it is very clear, second option is there. Okay, second option is correct option. Next question you can check on screen. A force of 5 newtons act on a body for 2 milliseconds. Okay, calculate the impulse. If the mass of the body is 5 grams, calculate the change of velocity. So in this what they are asking, okay, so impulse asking and change in moment also they are asking. Okay, so how much force is acting? 5 newtons of force is acting. Okay, so impulse what we discussed, the force into product of force into time. So force is 5 newtons acting and time is how many milliseconds? 2 milliseconds. 2 milliseconds mean, milli means how much? 10 to the power of minus 3. Okay, so here 5 2 is 10. Okay, 10 into 10 to the power of minus 3, that equal to 10 power of minus 2. Impulse units are what? Newton seconds. So impulse is, okay, impulse value we got 10 power of minus 2 Newton second. They are asking change in momentum. So we know that, okay, impulse I equal to what? So change in momentum I equal to m into v minus u. Okay, so they are asking what? V minus u. They are asking v minus u equal to what? I by impulse by mass. Here impulse value just now we got how much? 10 to the power of minus 2 by mass. The mass of the body is given. How much given? Mass of the body is 5 grams. 5 grams mean 10 to the power of minus 3 kilograms. 1 gram equal to 10 to the power of minus 3 kilogram. Here 10 power of minus 2 from 10 power of minus 3 cancel. 1 10 power of minus 1 is there. The 10 power of minus 1 sending to numerator 10. So divided by 5. Okay. So 5 1 ja, 5 2 ja. Okay. So 2 meter per second. Here impulse how much we got? 10 power of minus 2 Newton second, and change in velocity how much we got? 2 meter per second. The first option is correct option. Okay, so like that only Newton's second law based questions we observed. So next Newton's third law. So Newton's third law, so it is very easy. To every action there is equal and opposite reactions. So in the diagrams already on the board you can observe. So one ball thrown towards the rigid support, okay, rigid wall. So with what velocity they are throwing, with that velocity it is coming back. So to every action there is equal and opposite reaction. Okay, so in this part we discuss about the Newton's laws, first law, second law, third law, and okay, in the second law we discuss about the F equal to ma derivation based on that numericals, and another topic impulse, also based on impulse also numericals we observed. So next in the part 2 laws of motion, part 2 is there. Okay, so in the part 2 we'll discuss very important topics. Okay, connected bodies. Okay, atwood machine, the connected bodies. Okay, so the numericals very important connected bodies. So in the competitive examination, okay, maximum questions asking based on connected bodies. Okay, so along with string two bodies are, okay, attached. So one is on horizontal table, another one is hanging. Okay, so one body is on inclined plane, another one is hanging. So both the bodies are, okay, on two inclined planes. Okay, otherwise, so one pulley is there. Okay, so over the pulley two masses are hanged. Okay, these all how to solve, so detailedly we'll discuss in the part 2 laws of motion. Okay, so if you like this, okay, class, so please share this video, okay, and subscribe the channel. Okay, thank you.